Most of the entities in this world are related in one way or another. At times, finding relationship between entities can help you take valuable business decisions. I am Ayushi from Edureka, and today I'm going to talk about logistic regression, which is one such approach towards predicting relationships. Now let us see what all we're going to cover in today's training. So we'll start off the session by getting a quick introduction to what is regression. Then we'll see the different types of regression and we'll be discussing the what and why of logistic regression. So in this part, we'll discuss what exactly it is, where it is used, why it is used, and all those things. Moving ahead, we'll compare linear regression versus logistic regression along with the various real life use cases. And finally, towards the end, I'll be practically implementing logistic regression algorithm. So I hope you guys are clear with this agenda. So kindly drop me a quick confirmation or you can just reply me in the chat box so that I can proceed. Alright, Vishal says a yes. Swati gave me a thumbs up. Anita, Jagriti. Alright guys, since I'm getting confirmation from many of you, so let's quickly start off with the very first topic, what is regression? Now regression analysis is a predictive modeling technique. So it always involves predictions. So in this session, we'll just talk about predictive analysis and not prescriptive analysis. Now why? Because in prescriptive analysis, you need to have a good base and a strong hold on the predictive part first. Now it estimates a relationship between the dependent variable and an independent variable. So in my previous session guys, I've already explained you what exactly is a dependent variable and an independent variable. So for those of you who are not aware of these terminologies, let me give you a quick summary of it. So a dependent variable is nothing but a variable which you want to predict. Now let's say I want to know what will be the sales on 26th of this month. So sales becomes your dependent variable or you can say the target variable. Now this dependent variable or target variable are going to depend on a lot of factors. Let's say the number of products you sold till date or what is the season out there. Is there the availability of product or how is the product quality and all these things. So these are the never ending factors which are nothing but the different features that leads to sale. So these variables are called as your independent variable or you can say the predictor. Now, if you look at the graph over here, we have some values of x and we have values of y. Now, as you can see over here, if x increases, the value of y also increases. So let me explain you this with an example. Let's say we have data till the value of x, which is 6.75, and somebody asks you what will be the value of y when the value of x is 7. So the way which you can do it or how regression comes into the picture is by fitting a straight line by all these points and getting the value of m and c. So this is straight line guys and the formula for the straight line is y is equals to mx plus c. So using this we can try to predict the value of y. So here if you notice the x variable can increase as much as it can, but the y variable will increase according to x. So y is basically dependent on your x variable. So for any arbitrary value of x you can predict the value of y and this is always done through regression. So that is how regression is useful. Now regression is basically classified into three types, your linear regression, then your logistic regression and polynomial regression. So today we'll be discussing logistic regression. So let's move forward and understand the what and why of logistic regression. Now this algorithm is most widely used when the dependent variable or you can say the output is in the binary format. So here you need to predict the outcome of a categorical dependent variable. So the outcome should be always discrete or categorical in nature. Now by discrete, I mean the value should be binary or you can say you just have two values. It can either be 0 or 1. It can either be yes or a no, either be true or false or high or low. So only these can be the outcomes. So the value which you need to predict should be discrete or you can say categorical in nature. Whereas in linear regression, we have the value of y or you can say the value you need to predict is in a range. So that is how there is a difference between linear regression and logistic regression. Now you must be having a question, why not linear regression? Now guys, in linear regression, the value of y or the value which you need to predict is in a range. But in our case, as in the logistic regression, we just have two values. It can be either 0 or it can be 1. It should not entertain the values which is below 0 or above 1. But in linear regression, we have the value of y in the range. So here, in order to implement logistic regression, we need to clip this part. So we don't need the value that is below 0 or we don't need the value which is above 1. So since the value of y will be between only 0 and 1, that is the main rule of logistic regression, the linear line has to be clipped at 0 and 1. Now once we clip this graph, it would look somewhat like this. So here you are getting a curve which is nothing but three different straight lines. So here we need to make a new way to solve this problem. So this has to be formulated into an equation and hence we come up with logistic regression. So here the outcome is either 0 or 1, which is the main rule of logistic regression. So with this, our resulting curve cannot be formulated So hence our main aim to bring the values to 0 and 1 is fulfilled. So that is how we came up with logistic regression. Now here, once it gets formulated into an equation, it looks somewhat like this. So guys, this is nothing but a S curve, or you can say the sigmoid curve or sigmoid function curve. So this sigmoid function basically converts any value from minus infinity to infinity to your discrete values, which a logistic regression wants, or you can say the values which are in binary format, either 0 or 1. So if you see here, the values are either 0 or 1, and this is nothing but just a transition of it. But guys, there's a catch over here. So let's say I have a data point that is 0 0.8. Now, how can you decide whether your value is 0 or 1? Now, here you have the concept of threshold, which basically divides your line. So here threshold value basically indicates the probability of either winning or losing. So here by winning, I mean the value is equals to 1, and by losing, I mean the value is equals to 0. But how does it do that? Let's say I have a data point which is over here. Let's say my cursor is at 0 0.8. So here I'll check whether this value is less than my threshold value or not. Let's say if it is more than my threshold value, it should give me the result as 1. If it is less than that, then it should give me the result as 0. So here my threshold value is 0 0.5. Now I need to define that if my value, let's say 0 0.8, it is more than 0 0.5, then the value shall be rounded off to 1. And let's say if it is less than 0 0.5, let's say I have a value 0 0.2, then should reduce it to 0. So here you can use the concept of threshold value to find your output. So here it should be discrete, it should be either 0 or it should be 1. So I hope you caught this curve of logistic regression. So guys, this is the sigmoid S curve. So to make this curve, we need to make an equation. So let me address that part as well. So let's see how an equation is formed to imitate this functionality. So over here we have an equation of a straight line, which is y is equals to mx plus c. So in this case, I just have only one independent variable. But let's say if we have many independent variables, then the equation becomes m1x1 plus m2x2 plus m3x3 and so on till mn xn. Now let us put in b and x. So here the equation becomes y is equals to b1x1 plus b2x2 plus b3x3 and so on till bn xn plus c. So guys, your equation of the straight line has a range from minus infinity to infinity. But in our case, or you can say in logistic equation, the value which we need to predict, or you can say the y value, it can have the range only from 0 to 1. So in that case, we need to transform this equation. So to do that, what we had done, we have just divided the equation by 1 minus y. So now if y is equals to 0, so 0 over 1 minus 0 which is equals to 1. So 0 over 1 is again 0. And if we take y is equals to 1, then 1 over 1 minus 1 which is 0. So 1 over 0 is infinity. So here my range is now between 0 to infinity. But again we want the range from minus infinity to infinity. So for that what we'll do, we'll have the log of this equation. So let's go ahead and have the logarithmic of this equation. So here we have just transform it further to get the range between minus infinity to infinity. So over here we have log of y over 1 minus 1, and this is your final logistic regression equation. So guys, don't worry, you don't have to write this formula or memorize this formula. In Python, you just need to call this function which is logistic regression and everything will be automatically for you. So I don't want to scare you with the maths and the formulas behind it, but it's always good to know how this formula was generated. So I hope you guys are clear with how logistic regression comes into the picture. Next, let us see what are the major differences between linear regression versus logistic regression. Now, first of all, in linear regression, we have the value of y as a continuous variable, or the variable which we need to predict are continuous in nature. Whereas in logistic regression, we have the categorical variable. So here the value which you need to predict should be discrete in nature. It should be either 0 or 1, or it should have just two values to it. So for example, whether it is raining or it is not raining. Is it humid outside or it is not humid outside? Now, does it going to snow or it is not going to snow? So these are the few examples where you need to predict where the values are discrete, or you can just predict whether this is happening or not. Next, linear regression solves your regression problems. So here you have a concept of independent variable and a dependent variable. So here you can calculate the value of y which you need to predict using the value of x. So here your y variable, or you can say the value that you need to predict, are in a range. But whereas in logistic regression you have discrete values. So logistic regression basically solves your classification problem. So it can basically classify it and it can just give you result whether this event is happening or not. So I hope it is pretty much clear till now. Next, in linear regression, the graph that you have seen is a straight line graph. So over here you can calculate the value of y with respect to the value of x. Whereas in logistic regression, the curve that we got was a S curve, or you can say the sigmoid curve. So using the sigmoid function, you can predict your y values. So I hope you guys are clear with the differences between the linear regression and logistic regression. Moving ahead, let us see the various use cases wherein logistic regression is implemented in real life. So the very first is weather prediction. Now, logistic regression helps you to predict your weather. For example, it is used to predict whether it is raining or not, whether it is sunny, is it cloudy or not. So, all these things can be predicted using logistic regression. Whereas you need to keep in mind that both linear regression and logistic regression can be used in predicting the weather. So, in that case, linear regression helps you to predict what will be the temperature tomorrow, whereas logistic regression will only tell you whether it's going to rain or not, or whether it's cloudy or not, whether it's going to snow or not. So these values are discrete. Whereas if you apply linear regression, you'll be predicting things like what is the temperature tomorrow or what is the temperature day after tomorrow and all those things. So these are the slight differences between linear regression and logistic regression. Now moving ahead, we have classification problem. So Python performs multi-class classification. So here it can help you tell whether it's a bird or it's not a bird. Then you can classify different kind of mammals. Let's say whether it's a dog or it's not a dog. Similarly, you can check it for reptile, whether it's a reptile or not a reptile. So in logistic regression, it can perform multi-class classification. So this point I have already discussed that it is used in classification problems. Next, it also helps you to determine the illness as well. So let me take an example. Let's say a patient goes for a routine checkup in a hospital. So what doctor will do, it will perform various tests on the patient and will check whether the patient is actually ill or not. So what will be the features? So doctor can check the sugar level, the blood pressure, then what is the age of the patient? Is it very small or is it an old person? Then what is the previous medical history of that patient? And all of these features will be recorded by the doctor. And finally, doctor checks the patient data and determines the outcome of an illness and the severity of illness. So using all the data, a doctor can identify whether a patient is ill or not. So these are the various use cases in which you can use logistic regression. Now I guess enough of theory part. So let's move ahead and see some of the practical implementation of logistic regression. So over here I'll be implementing two projects wherein I have the data set of a Titanic. So over here we'll predict what factors made people more likely to survive the sinking of the Titanic ship. And in my second project, we'll see the data analysis on the SUV cars. So over here we have the data of the SUV cars, who can purchase it, and what factors made people more interested in buying SUV. So these will be the major questions as to why you should implement logistic regression and what output will you get by it. So let's start by the very first project, that is Titanic data analysis. So some of you might know that there was a ship called as Titanic which basically hit an iceberg and it sunk to the bottom of the ocean. And it was a big disaster at that time because it was the first voyage of the ship and it was supposed to be really strongly built and one of the best ships of that time. So it was a big disaster of that time, and of course, there's a movie about this as well. So many of you might have watched it. So what we have data of the passengers, those who survived and those who did not survive in this particular tragedy. So what you have to do, you have to look at this data and analyze which factors would have been contributed the most to the chances of a person's survival on the ship or not. So using the logistic regression, we can predict whether the person survived or the person died. Now, apart from this, we'll also have a look with the various features along with that. So first, let us explore the data set. So over here, we have the index value. Then the first column is passenger ID. Then my next column is survived. So over here, we have two values, a 0 and a 1. So 0 stands for did not survive and 1 stands for survived. So this column is categorical where the values are discrete. Next, we have passenger class. So over here, we have three values, 1, 2, and 3. So this basically tells you that whether a passenger is traveling in the first class, second class, or third class. Then we have the name of the passenger, we have the sex, or you can say the gender of the passenger, whether passenger is a male or female. Then we have the age, we have the SIB-SP. So this basically means the number of siblings or the spouses aboard the Titanic. So over here we have values such as 1, 0, and so on. Then we have patch. So patch is basically the number of parents or children aboard the Titanic. So over here we also have some values. Then we have the ticket number, we have the fare, we have the cabin number, and we have the embarked column. So in my embarked column, we have three values. We have S, C, and Q. So S basically stands for Southampton, C stands for Cherbourg, and Q stands for Queenstown. So these are the features that we'll be applying our model on. So here we'll perform various steps and then we'll be implementing logistic regression. So now these are the various steps which are required to implement any algorithm. So now in our case, we are implementing logistic regression. So our very first step is to collect your data or to import the libraries that are used for collecting your data and then taking it forward. Then my second step is to analyze your data. So over here, I can go to the various fields and then I can analyze the data. I can check, did the females or children survive better than the males, or did the rich passenger survive more than the poor passenger, or did the money matter, as in who paid more to get into the ship, were they evacuated first, and what about the workers? Does the worker survived, or what is the survival rate if you were the worker in the ship and not just a traveling passenger? So all of these are very, very interesting questions, and you would be going through all of them one by one. So in this stage, you need to analyze your data and explore your data as much as you can. Then my third step is to wrangle your data. Now data wrangling basically means cleaning your data. So over here you can simply remove the unnecessary items, or if you have a null values in the data set, you can just clear that data and then you can take it forward. So in this step you can build your model using the trained data set and then you can test it using the test. So over here you will be performing a split, which basically split your data set into training and testing data set. And finally you will check the accuracy so as to ensure how much accurate your values are. So I hope you guys got these 5 steps that we're going to implement in logistic regression. So now let's go into all these steps in detail. So number one, we have to collect your data, or you can say import the libraries. So let me just show you the implementation part as well. So I'll just open my Jupyter notebook and I'll just implement all of these steps side by side. So guys, this is my Jupyter notebook. So first let me just rename the Jupyter notebook to, let's say, Titanic data analysis. Now our first step was to import all the libraries and collect the data. So let me just import all the libraries first. So first of all, I'll import pandas. So pandas is used for data analysis. So I'll say import pandas as PD. Then I'll be importing NumPy. So I'll say import NumPy as NP. So NumPy is a library in Python which basically stands for numerical Python, and it is widely used to perform any scientific computation. Next, we'll be importing Seaborn. So Seaborn is a library for statistical plotting. So I'll say import Seaborn as SNS. I'll also import Matplotlib. So Matplotlib library is again for plotting. So I'll say import matplotlib.pyplot as PLT. Now to run this library in Jupyter Notebook, all I have to write in is percentage matplotlib inline. Next, I'll be importing one module as well so as to calculate the basic mathematical functions. So I'll say import maths. So these are the libraries that I'll be needing in this Titanic data analysis. So now let me just import my data set. So I'll take a variable, let's say Titanic data, and using the pandas, I will just read my CSV, or you can say the data set. I'll write the name of my data set, that is titanic.csv. Now I have already showed you the data set. So over here, let me just print the top 10 rows. So for that, I'll just say, I'll take the variable Titanic data dot head and I'll say the top 10 rows. So now I'll just run this. So to run this, so I just have to press Shift plus Enter, or else you can just directly click on the cell. So over here, I have the index, we have the passenger ID, which is nothing but again the index which is starting from 1. Then we have the survived column, which has the categorical values, or you can say the discrete values, which is in the form of 0 or 1. Then we have the passenger class, we have the name of the passenger, sex, age, and so on. So this is the dataset that I'll be going forward with. Next, let us print the number of passengers which are there in this original dataset. So for that, I'll just simply type in print. I'll say number of passengers, and using the length function I can calculate the total length. So I'll say length, and inside this I'll be passing this variable which is Titanic data. So I'll just copy it from here, I'll just paste it dot index. And next, so let me just print this one. So here the number of passengers which are there in the original data set we have is 891. So around this number were traveling in the Titanic ship. So over here my first step is done, where you have just collected data, imported all the libraries, and find out the total number of passengers which are traveling in Titanic. So now let me just go back to presentation and let's see what is my next step. So we're done with the collecting data. Next step is to analyze your data. So over here we'll be creating different plots to check the relationship between variables, as in how one variable is affecting the other. So you can simply explore your dataset by making use of various columns, and then you can plot a graph between them. So you can either plot a correlation graph, you can plot a distribution graph. It's up to you guys. So let me just go back to my Jupyter notebook and let me analyze some of the data. Over here, my second part is to analyze data. So I just put this in header 2. Now to put this in header 2, I just have to go on code, click on markdown, and I just run this. So first let us plot a count plot where you compare between the passengers who survived and who did not survive. So for that I'll be using the Seaborn library. So over here I have imported Seaborn as SNS. So I don't have to write the whole name. I'll simply say sns.countplot. I'll say X is who survived, and the data that I'll be using is the Titanic data, or you can say the name of variable in which you have stored your data set. So now let me just run this. So over here, as you can see, I have survived column on my x-axis, and on the y-axis, I have the count. So 0 basically stands for did not survive, and 1 stands for the passengers who did survive. So over here, you can see that around 550 of the passengers who did not survive, and there were around 350 passengers who only survived. So here you can basically conclude that there are very less survivors than non-survivors. So this was the very first plot. Now let us plot another plot to compare the sex as to whether out of all the passengers who survived and who did not survive, how many were men and how many were female. So to do that, I'll simply say sns.countplot. I'll add the hue as sex. So I want to know how many females and how many males survived. Then I'll be specifying the data. So I'm using Titanic data set. And let me just run this. Okay, I've done a mistake over here. So over here you can see I have survived column on the x-axis and I have the count on the y. Now, so here your blue color stands for your male passengers and orange stands for your female. So as you can see here, the passengers who did not survive, that has a value 0. So we can see that majority of males did not survive. And if we see the people who survived, here we can see the majority of females survived. So this basically concludes the gender of the survival rate. So it appears on average women were more than 3 times more likely to survive than men. Next, let us plot another plot where we have the hue as the passenger class. So over here we can see which class that the passenger was traveling in, whether it was traveling in class 1, 2 or 3. So for that, I'll just write the same command. I'll say sns.countplot. I'll keep my x-axis as subject only. I'll change my hue to passenger class. So my variable is named as P class. And the data set that I'll be using is Titanic data. So this is my result. So over here you can see I have blue for first class, orange for second class and green for the third class. So here the passengers who did not survive were majorly of the third class, or you can say the lowest class or the cheapest class to get into the Titanic. And the people who did survive majorly belong to the higher classes. So here 1 and 2 has more rise than the passenger who were traveling in the third class. So here we have concluded that the passengers who did not survive were majorly of third class, or you can say the lowest class. And the passengers who were traveling in first and second class would tend to survive more. Next, let us plot a graph for the age distribution. Over here, I can simply use my data. So I'll be using pandas library for this. I'll declare an array and I'll pass in the column that is age. So I plot and I want a histogram. So I'll say plot.hist. So you can notice over here that we have more of young passengers, or you can say the children between the ages 0 to 10. And then we have the average age people. And if you go ahead, lesser would be the population. So this is the analysis on the age column. So we saw that we have more young passengers and more mediocre age passengers which are traveling in the Titanic. So next let me plot a graph for fare as well. So I'll say Titanic data. I'll say fare. And again I'll plot a histogram. So I'll say hist. So here you can see the fare size is between 0 to 100. Now let me add the bin size so as to make it more clear. So over here I'll say bin is equals to, let's say 20, and I'll increase the figure size as well. So I'll say fig size. Let's say I'll give the dimensions as 10 by 5. So it is bins. So this is more clear now. Next let us analyze the other columns as well. So I'll just type in Titanic data and I want the information as to what all columns are left. So here we have passenger ID, which I guess it's of no use. Then we have see how many passengers survived and how many did not. We also see the analysis on the gender basis. We saw whether female tend to survive more or the men tend to survive more. Then we saw the passenger class, whether passenger is traveling in the first class, second class or third class. Then we have the name. So in name we cannot do any analysis. We saw the sex, we saw the age as well. Then we have SIB-SP. So this stands for the number of siblings or the spouses which are aboard the Titanic. So let us do this as well. So I'll say sns.countplot. I'll mention x as SIB-SP and I'll be using the Titanic data. So you can see the plot over here. So over here you can conclude that it has the maximum value on 0. So you can conclude that neither a children nor a spouse was on board the Titanic. Now second most highest value is 1. And then we have very less values for 2, 3, 4, and so on. Next, if I go above, we saw this column as well. Similarly, you can do for Parj. So next we have Parj, or you can say the number of parents or children which were aboard the Titanic. So similarly, you can do this as well. Then we have the ticket number. So I don't think so any analysis is required for ticket. Then we have fare. So fare we have already discussed. As in the people who tend to travel in the first class usually pay the highest fare. Then we have the cabin number and we have embarked. So these are the columns that we'll be doing data wrangling on. So we have analyzed the data and we have seen quite a few graphs in which we can conclude which variable is better than the another or what is the relationship they hold. So third step is my data wrangling. So data wrangling basically means cleaning your data. So if you have a large data set, you might be having some null values or you can say NaN values. So it's very important that you remove all the unnecessary items that are present in your data set. So removing this directly affects your accuracy. So I'll just go ahead and clean my data by removing all the NaN values and unnecessary columns which has a null value in the data set. So next I'll be performing data wrangling. So first of all, I'll check whether my data set is null or not. So I'll say Titanic data, which is the name of my data set, and I'll say is null. So this will basically tell me what all values are null and it will return me a Boolean result. So this basically checks the missing data and your result will be in Boolean format, as in the result will be true or false. So false means if it is not null and true means if it is null. So let me just run this. So over here you can see the values as false or true. So false is where the value is not null and true is where the value is null. So over here you can see in the cabin column we have the very first value which is null. So we have to do something on this. So you can see that we have a large data set, so the counting does not stop. And we can actually see the sum of it. We can actually print the number of passengers who have the NaN value in each column. So I'll say Titanic underscore data is null and I want the sum of it. So I'll say dot sum. So this will basically print the number of passengers who have the NaN values in each column. So we can see that we have missing values in each column, that is 177. Then we have the maximum value in the cabin column. And we have very less in the embarked column, that is 2. So here if you don't want to see these numbers, you can also plot a heat map and then you can visually analyze it. So let me just do that as well. So I'll say sns.heatmap. I'll say y tick labels to false. So I'll just run this. So as we have already seen that there were 3 columns in which missing data value was present. So this might be age. So over here almost 20% of age column has a missing value. Then we have the cabin columns. So this is quite a large value. And then we have 2 values for embarked column as well. Add a CMAP for color coding. So I'll say CMAP. So if I do this, so the graph becomes more attractive. So over here, your yellow stands for true, or you can say the values are null. So here we have concluded that we have the missing value of age. We have a lot of missing values in the cabin column, and we have very less value which is not even visible in the embarked column as well. So to remove these missing values, you can either replace the values and you can put in some dummy values to it, or you can simply drop the column. So here let us first pick the age column. So first let me just plot a box plot and they will analyze with having a column as age. So I'll say sns dot box plot. I'll say x is equals to passenger class. So it's P class. I'll say y is equals to age. And the data set that I'll be using is Titanic set. So I'll say data is equals to Titanic data. You can see the age in first class and second class tends to be more older rather than we have it in the third class. Well, that depends on the experience, how much you earn, or might be there n number of reasons. So here we concluded that passengers who were traveling in class 1 and class 2 are tend to be older than what we have in the class 3. So we have found that we have some missing values in M. Now one way is to either just drop the column or you can just simply fill in some values to that. So this method is called as imputation. Now to perform data wrangling or cleaning, let us first print the head of the data set. So I'll say Titanic.head, sorry, it's Titanic underscore data. Let's say I just want the 5 rows. So here we have survive, which is again categorical. So in this particular column, I can apply logistic regression. So this can be my y value or the value that I need to predict. Then we have the passenger class, we have the name. Then we have ticket number, fare, cabin. So over here we have seen that in cabin we have a lot of null values, or you can say the NaN values, which is quite visible as well. So first of all, we'll just drop this column. So for dropping it, I'll just say Titanic underscore data, and I'll simply type in drop and the column which I need to drop. So I have to drop the cabin column. I'll mention the axis equals to 1, and I'll say in place also to true. So now again, I'll just print the head and let us see whether this column has been removed from the data set or not. So I'll say Titanic dot head. So as you can see here, we don't have cabin column anymore. Now you can also drop the NA values. So I'll say Titanic data dot drop all the NA values, or you can say NaN, which is not a number. And I'll say in place is equals to true. It's Titanic. So over here, let me again plot the heat map, and let's say what the values which were before showing a lot of null values, has it been removed or not. So I'll say sns.heatmap, I'll pass in the data set, I'll check it is null. I'll say y tick labels is equals to false, and I don't want color coding, so again I'll say false. So this will basically help me to check whether my values has been removed from the data set or not. So as you can see here, I don't have any null values, so it's entirely black. Now you can actually know the sum as well, so I'll just go above. So I'll just copy this part and I just use the sum function to calculate the sum. So here that tells me that data set is clean, as in the data set does not contain any null value or any NaN value. So now we have wrangled our data, or you can say clean our data. So here we have done just one step in data wrangling, that is just removing one column out of it. Now you can do a lot of things. You can actually fill in the values with some other values, or you can just calculate the mean and then you can just fit in the null values. But now if I see my data set, so I'll say Titanic data dot head. But now if I see over here, I have a lot of string values. So this has to be converted to categorical variables in order to implement logistic regression. So what we will do, we will convert this to categorical variable into some dummy variables. And this can be done using pandas, because logistic regression just take two values. So whenever you apply machine learning, you need to make sure that there are no string values present, because it won't be taking these as your input variables. So using string, you don't have to predict anything. But in my case, I have the survived column. So I need to predict how many people tend to survive and how many did not. So 0 stands for did not survive and 1 stands for survive. So now let me just convert these variables into dummy variables. So I'll just use pandas and I'll say pd.getDummies. You can simply press tab to autocomplete. I'll say Titanic data and I'll pass the sex. So you can just simply click on shift plus tab to get more information on this. So here we have the type data frame and we have the passenger ID, survived, and the passenger class. So if you run this, you'll see that 0 basically stands for not a female and 1 stands for it is a female. Similarly for male, 0 stands for it's not male and 1 stands for male. Now we don't require both these columns, because one column itself is enough to tell us whether it's male or you can say female or not. So let's say if I want to keep only male, now I'll say if the value of male is 1, so it is definitely a male and it is not a female. So that is how you don't need both of these values. So for that, I'll just remove the first column, let's say female. So I'll say drop first and true. So over here it has given me just one column which is male and has the value 0 and 1. Now let me just set this as a variable, let's say sex. So over here I can say sex dot head. I just want to see the first 5 rows. Oh, sorry, it's dot. So this is how my data looks like. Now here we have done it for sex. Then we have the numerical values in age, we have the numerical values in spouses, then we have the ticket number, we have the fare, and we have embarked as well. So in embarked, the values are in S, C, and Q. So here also we can apply this get dummy function. So let's say I'll take a variable, let's say embark. I'll use the pandas library. I'll enter the column name, that is embarked. So let me just print the head of it. So I'll say embark.head. So over here we have C, Q, and S. Now here also we can drop the first column, because these two values are enough whether the passenger is either traveling for Q, that is Queenstown, S for Southampton, and if both the values are 0, then definitely the passenger is from Cherbourg, that is the third value. So you can again drop the first value. So I'll say drop and true. Let me just run this. So this is how my output looks like. Now similarly you can do it for passenger class as well. So here also we have three classes, 1, 2, and 3. So I'll just copy the whole statement. So let's say I want the variable name, let's say PCL. I'll pass in the column name, that is P class, and I'll just drop the first column. So here also the values would be 1, 2 or 3, and I'll just remove the first column. So here we just left with 2 and 3. So if both the values are 0, then definitely the passenger is traveling in the first class. Now we have made the values as categorical. Now my next step would be to concatenate all these new rows into a data set. Or you can say Titanic data. Using the pandas, we'll just concatenate all these columns. So I'll say p.concat, and I'll say we have to concatenate sex, we have to concatenate embark and PCL. And then I'll mention the access to one. I'll just run this. Okay, I need to print the head. So over here you can see that these columns have been added over here. So we have the male column, which basically tells whether a person is male or it's a female. Then we have the embark, which is basically Q and S. So if it's traveling from Queenstown, the value would be 1, else it would be 0. And if both of these values are 0, it is definitely traveling from Cherbourg. Then we have the passenger class as 2 and 3. So if the value of both these is 0, then the passenger is traveling in class 1. So I hope you got this till now. Now these are the irrelevant columns that we have it over here. So we can just drop these columns. We'll dropping P class, the embarked column, and the sex column. So I'll just type in Titanic data dot drop, and I'll mention the columns that I want to drop. So I'll say I'll even delete the passenger ID because it's nothing but just the index value which is starting from 1. So I'll drop this as well. Then I don't want name as well, so I'll delete name as well. Then what else we can drop? We can drop the ticket as well. And then I'll just mention the access, and I'll say in place is equals to true. Okay, so my column name starts from uppercase. So these has been dropped. Now let me just print my data set again. So this is my final data set, guys. We have the survived column which has the value 0 and 1. Then we have the passenger class. Oh, we forgot to drop this as well. So no worries, I'll drop this again. So now let me just run this. So over here we have the survived, we have the age, we have the SIB SP, we have the parch, we have fair, male, and these we have just converted. So here we have just performed data wrangling, or you can say clean the data, and then we have just converted the values of gender to male, then embark to QNS, and the passenger class to 2 and 3. So this was all about my data wrangling or just cleaning the data. Then my next step is training and testing your data. So here we will split the dataset into train subset and test subset. And then what we'll do, we'll build a model on the train data and then predict the output on your test dataset. So let me just go back to Jupyter and let us implement this as well. Over here, I need to train my dataset. So I'll just put this in heading 3. So over here, you need to define your dependent variable and independent variable. So here, my y is the output, or you can say the value that I need to predict. So over here, I'll write Titanic data. I'll take the column which is survived. So basically, I have to predict this column whether the passenger survived or not. And as you can see, we have the discrete outcome, which is in the form of 0 and 1. And rest all the things, we can take it as a features, or you can say independent variable. So I'll say Titanic data dot drop. So we'll just simply drop this survived, and all the other columns will be my independent variable. So everything else are the features which leads to the survival rate. So once we have defined the independent variable and the dependent variable, next step is to split your data into training and testing subset. So for that, we'll be using sklearn. I just type in from sklearn.cross-validation, import train test split. Now here, if you just click on shift and tab, you can go to the documentation and you can just see the examples over here. I'll click on plus to open it. And then I just go to examples and see how you can split your data. So over here you have X train, X test, Y train, Y test. And then using this train test split, you can just pass in your independent variable and dependent variable and just define a size and a random state to it. So let me just copy this and I'll just paste it over here. Over here we'll train test, then we have the dependent variable train and test, and using the split function we'll pass in the independent and dependent variable, and then we'll set a split size. So let's say I'll put it as 0.3. So this basically means that your data set is divided in 0.3. That is in 70-30 ratio. And then I can add any random state to it. So let's say I'm applying 1. This is not necessary. If you want the same result as that of mine, you can add the random state. So this will basically take exactly the same sample every time. Next, I have to train and predict by creating a model. So here logistic regression will grab from the linear regression. So next I'll just type in from sklearn.linear model import logistic regression. Next I'll just create the instance of this logistic regression model. So I'll say log model is equals to logistic regression. Now I just need to fit my model. So I'll say log model dot fit and I'll just pass in my x train and y train. Alright, so here it gives me all the details of logistic regression. So here it gives me the class weight, dual, fit, intercept, and all those things. Then what I need to do, I need to make prediction. So I'll take a variable, let's say predictions, and I'll pass on the model to it. So I'll say log model dot predict, and I'll pass in the value that is x test. So here we have just created a model, fit that model, and then we had made predictions. So now to evaluate how my model has been performing, so you can simply calculate the accuracy or you can also calculate a classification report. So don't worry guys, I'll be showing both of these methods. So I'll say from sklearn.metrics import classification report. So over here I'll use classification report and inside this I'll be passing in y test and the predictions. So guys, this is my classification report. So over here I have the precision, I have the recall, we have the F1 score, and then we have support. So here we have the value of precision as 75, 72 and 73, which is not that bad. Now, in order to calculate the accuracy as well, you can also use the concept of confusion matrix. So if you want to print the confusion matrix, I'll simply say from sklearn.metrics import confusion matrix first of all, and then we'll just print this. So here my function has been imported successfully. So I'll say confusion matrix and I'll again pass in the same variables, which is y test and predictions. So I hope you guys already know the concept of confusion matrix. So can you guys give me a quick confirmation as to whether you guys remember this confusion matrix concept or not? So if not, I can just quickly summarize this as well. Okay, Jagriti says a yes. Okay, Swati is not clear with this. So I'll just tell you in a brief what confusion matrix is all about. So confusion matrix is nothing but a 2 by 2 matrix which has a 4 outcomes. This basically tells us that how accurate your values are. So here we have the column as predicted no, predicted y, and we have actual no and an actual yes. So this is the concept of confusion matrix. So here let me just feed in these values which we have just calculated. So here we have 105, 105, 21, 25 and 63. So as you can see here we have got 4 outcomes. Now 105 is the value where our model has predicted no and in reality it was also a no. So here we have predicted no and an actual no. Similarly, we have 63 as a predicted yes. So here the model predicted yes and actually also it was a yes. So in order to calculate the accuracy, you just need to add the sum of these two values and just divide the whole by the sum. So here these two values tells me where the model has actually predicted the correct output. So this value is also called as true negative. This is called as false positive. This is called as true positive and this is called as false negative. Now in order to calculate the accuracy, you don't have to do it manually. So in Python, you can just import accuracy score function and you can get the results from that. So I'll just do that as well. So I'll say from sklearn.metrics import accuracy score and I'll simply print the accuracy. And I'll pass in the same variables that is y test and predictions. So over here it tells me the accuracy as 78, which is quite good. So over here if you want to do it manually, you have to plus these two numbers which is 105 plus 63. So this comes out to almost 168 and then you have to divide it by the sum of all the four numbers. So 105 plus 63 plus 21 plus 25. So this gives me a result of 214. So now if you divide these two numbers, you'll get the same accuracy that is 78% or you can say 0.78. So that is how you can calculate the accuracy. So now let me just go back to my presentation and let's see what all we have covered till now. So here we have first split our data into train and test subset. Then we have built our model on the trained data and then predicted the output on the test data set. And then my fifth step is to check the accuracy. So here we have calculated accuracy to almost 78%, which is quite good. You cannot say that accuracy is bad. So here it tells me how accurate your results are. So here my accuracy score defines that, and hence we got a good accuracy. So now moving ahead, let us see the second project, that is SUV data analysis. So in this, a car company has released new SUV in the market. And using the previous data about the sales of their SUV, they want to predict the category of people who might be interested in buying this. So using the logistic regression, you need to find what factors made people more interested in buying this SUV. So for this, let us see a data set where I have user ID, I have gender as male and female, then we have the age, we have the estimated salary, and then we have the purchased column. So this is my discrete column, or you can say the categorical column. So here we just have the value that is 0 and 1. And this column we need to predict whether a person can actually purchase a SUV or not. So based on these factors, we will be deciding whether a person can actually purchase a SUV or not. So we know the salary of a person, we know the age. And using these, we can predict whether a person can actually purchase a SUV or not. So let me just go to my Jupyter notebook and let us implement logistic regression. So guys, I will not be going through all the details of data cleaning and analyzing the part. So that part I'll just leave it on you. So just go ahead and practice as much as you can. Alright. So my second project is SUV predictions. Alright. So first of all, I have to import all the libraries. So I say import numpy as np. And similarly, I'll do the rest of it. Alright. So now let me just print the head of this data set. So this we've already seen that we have columns as user ID, we have gender, we have the age, we have the salary, and then we have to calculate whether the person can actually purchase a SUV or not. So now let us just simply go on to the algorithm part. So we'll directly start off with the logistic regression, or how you can train a model. So for doing all those things, we first need to define your independent variable and a dependent variable. So in this case, I want my x that is an independent variable. I say dataset.ilog. So here I'll be specifying all the rows. So colon basically stands for that. And in the columns, I want only 2 and 3 dot values. So here it should fetch me all the rows and only the second and third column, which is age and estimated salary. So these are the factors which will be used to predict the dependent variable, that is purchase. So here my dependent variable is purchase. And the dependent variable is of age and salary. So I'll say dataset.ilog. I'll have all the rows and I just want fourth column, that is my purchased column dot values. Alright, so I've just forgot one square bracket over here. Alright. So over here I have defined my independent variable and dependent variable. So here my independent variable is age and salary and dependent variable is the column purchase. Now you must be wondering, what is this ilog function? So ilog function is basically an indexer for pandas data frame, and it is used for integer based indexing, or you can also say selection by index. Now let me just print these independent variables and dependent variable. So if I print the independent variable, I have the age as well as the salary. Next, let me print the dependent variable as well. So over here you can see I just have the values in 0 and 1. So 0 stands for did not purchase. Next, let me just divide my dataset into training and test subset. So I'll simply write in from sklearn.crosssplit.crossvalidation import train test. Next, I'll just press shift and tab. And over here, I'll go to the examples and just copy the same line. So I'll just copy this. I'll remove the points. Now I want the text size to be, let's say, 25. So I have divided the train and test split in 75-25 ratio. Now let's say I'll take the random state as 0. So random state basically ensures the same result. Or you can say the same samples taken whenever you run the code. So let me just run this. Now you can also scale your input values for better performing. And this can be done using standard scaler. So let me do that as well. So I'll say from sklearn.preprocessing import standard scaler. Now why do we scale it? Now if you see our data set, we are dealing with large numbers. Well, although we are using a very small data set, so whenever you're working in a prod environment, you'll be working with large data set where you'll be using thousands and hundred thousands of tuples. So their scaling down will definitely affect the performance by a large extent. So here let me just show you how you can scale down these input values. And then the pre-processing contains all your methods and functionality which is required to transform your data. So now let us scale down for test as well as a training data set. So I'll first make an instance of it. So I'll say standard scalar. Then I'll have xtrain. I'll say sc.fit, fit underscore transform. And I'll pass in my xtrain variable. And similarly, I can do it for test, wherein I'll pass the x test. Alright. Now my next step is to import logistic regression. So I'll simply apply logistic regression by first importing it. So I'll say from sklearn.linear model import logistic regression. Now over here I'll be using classifier. So I'll say classifier dot is equals to logistic regression. So over here I'll just make an instance of it. So I'll say logistic regression. And over here I'll just pass in the random state, which is 0. And now I'll simply fit the model. And I simply pass in xtrain and ytrain. So here it tells me all the details of logistic regression. Then I have to predict the value. So I'll say ypred is equals to classifier, then predict function, and then I just pass in xtest. So now we have created the model, we have scaled down our input values, then we have applied logistic regression, we have predicted the values, and now we want to know the accuracy. So to know the accuracy, first we need to import accuracy score. So I'll say from sklearn.metrics import accuracy score, and using this function we can calculate the accuracy, or you can manually do that by creating a confusion matrix. So I'll just pass in my y test and my y predicted. Alright, so over here I get the accuracy as 89%. So if you want to know the accuracy in percentage, so I just have to multiply it by 100, and if I run this, so it gives me 89%. So I hope you guys are clear with whatever I have taught you today. So here I have taken my independent variables as age and salary, and then we have calculated that how many people can purchase the SUV. And then we have calculated our model by checking the accuracy. So over here we get the accuracy as 89, which is great. Alright guys, so that is it for today. Well, thank you everyone. Hope you had a great time. Bye bye.